Hello guys, welcome back to the channel Just Krishna. So in today's video we are going to count number of odd digits in a number. So here we are given n digit and we have to check for number of odd digits in a number. So if n is equal to 5, then 5 is the only odd digit in this number. If n is equal to 25, then there is like again 5 is the only odd digit. uh, and if we check for n equal to 15, then number of odd digits are 2, as 1 and 5 both are odd digits. So basically odd digit is a number that is not divisible by 2, and it leaves the remainder 1 when it is divided by 2. So the approach that we can follow is, first we can check each element of a digit, uh, like whether it is a odd number or not, and we can simply do count plus plus. So this is the coding implementation. So like we can iterate the loop by 1, and like once we iterate the loop, we can see like here we have declared two variables as cnt and digit, and like we have iterated the loop till the number becomes 0. So the line number 7, what it does is it returns the remainder of a number when it is like when we divide any number by 10. So the resultant remainder is the last digit of a number. For example, if we consider 15 mod 10, then the remainder will be 5. And what we will do is, basically we will check if 5 mod 2 is 1 or not. If 5 mod 2 is 1, then we'll simply increment the count by 1. And then at line number 12, what we can do is we will keep shrinking the number until it becomes 0. That is, basically we are dividing the number by 10 and it will return the quotient. So when we will do 15 divided by 10, then the quotient will be 1. So it will like keep on shrinking, and we will iterate the loop until the digit becomes 0, and in case if n equal to 0, then we'll return 1. And after that we'll simply like once loop is completed, like terminated, we'll return the count, and we can run the code to check the output. It is evaluated and yes, it is accepted. So we can submit the code and analyze the space and time complexity. So the time complexity of the code will be big of log n, as the loop will be iterated exactly as the number of digits in a number. Like it totally, we can view the advanced analysis, and like where n is the input integer, as while loop is iterated based on the number of digits in n. So log n basically means, like if there will be 3 digits, then loop will be iterated 3 times. So it is completely dependent on number of digits in a number. So how log n, basically what we can see is, here is the note section. So what we can look is for the intuition. Think of a logarithm as the opposite of exponentiation. So if we will do 10 raised to 3 equal to 1000, that's a number with 4 digit, right? And if we will do log 10 base 1000, it will be 3. So basically it tells you how many times we are dividing 10. Okay, so it is opposite of exponentiation. So that's exactly what we are doing in our case. Like how log, because like loop is iterated as like it is directly proportional to the number of digits in a number. So 3 tells us like how many times we can divide by 10. Okay, like here in this case 1000 equal to 3, this tells us how many times you can divide by 10 before dropping below 1. That's exactly how our, even like how our loop is also working. and like space complexity will be big of 1 as no additional space is required. So yeah, that's it for this video. See you in the next one. Until then, keep coding, keep exploring, keep smiling. Toodles.